All right, learning target number 2 for our prerequisites is patterns and linear functions. So we're going to start off discussing a few definitions of some things that we need to make sure we know before we get into actually representing patterns in table format or graph format. So the first definition I want to look at is dependent variable. The dependent variable, so here's the definition for dependent variable: changes in response to another variable. Now, dependent, think about if you live at home, you are a dependent part of your home because you depend on your parents for a lot of things. So changes for the dependent variable are in response to another variable. Whatever happens to this other variable, it's going to affect our dependent variable. So one thing you could think of is it depends, I'm going to put that in quotations, depends on another value. So whatever that other value is, it will affect the dependent variable. So the second definition that we have is independent variable. And you could probably develop your own definition for independent variable. The independent variable, what we're going to write is that it provides the input values. And we're going to talk more about input here in just a minute, but it provides the values that you're going to substitute in. It's independent. It can do whatever it wants or be whatever it wants, and there can be restrictions, but for the most part it's independent, and whatever happens with our independent variable, it's going to affect our dependent variable. Now, inputs, which was in our last definition, inputs are the values of the independent variable, which we just discussed this, values of the independent variable you substitute in. And we just talked about that. You substitute in whatever variable, whatever value you want for your variable. If there are restrictions, you will be restricted, but otherwise anything that you want for your variable, for your independent or your input, which is the same thing, you put in there, you substitute in, and what you're going to get is an output. The outputs are the solutions or the values of the independent variable, of the dependent. The solutions or the values of the dependent variable. So whatever you put into your function, your inputs, you will have outputs, and those are the solutions. It's also considered your dependent variable. That's what values you will have as a result. So you need to keep these definitions in mind as we start going through some of these representations of patterns and talking about linear functions. And think about linear functions, talking about ones that form lines. Whether we connect the dots or not in graphing, it does create a line. So let's look at problem 1. We have a pattern here of rectangles. And it shows right now we want to find out the relationship between the number of rectangles in the picture and the perimeter that they form. So perimeter, vocabulary word you need to make sure that you know. Perimeter is the distance around an object, in this case our rectangle. When you have two rectangles, it's the distance around. We're not worried about that line down the middle. Same thing with three rectangles. We're not worried about those two lines down the middle. Perimeter is the distance around. So we want to discover or look at the relationship between those two, and then we want to represent that relationship using a table, words, an equation, and a graph. So this does take some time. We've got to have a table, we've got to write it in our own words, we've got to create ourselves an equation, and we're going to have to graph it. So 4 things that we've got to do here in this one problem. So let's start out by creating our table, which is the easiest place to start and will help us with the rest of our problem. So number 1, we're going to create a table. And let's just think about what all we have here. We are comparing the relationship between the number of rectangles and the perimeter. So when I set up my table, I'm going to write number of rectangles. That's going to be one part of my table. And the other part of my table is going to be perimeter. Well, let's think for a minute, what is going to be the dependent and what's going to be the independent variable? Think about this. Do the number of rectangles depend on the perimeter, or does the perimeter depend on the number of rectangles? And in this case, the perimeter is going to depend on how many rectangles you have in the picture. I can have any amount of rectangles that I want, but my output or my dependent variable is going to be the perimeter. So your perimeter, thinking about a coordinate plane, is going to be the y value. It's your dependent variable. Therefore, the number of rectangles will be your x value. It is independent. It can be whatever it wants to be. So what I'm going to do is I'm actually going to have a third column in my table, and that's just going to be my ordered pair, my x, y, so that when I start to graph, I will already have my ordered pairs lined up for myself. Alright, so let's go ahead and let's just look at this. When I have one rectangle, what's my perimeter going to be? Now I can set this up algebraically, and that's what I'm going to do here to show you how to get perimeter. Rectangles have 2 widths and 2 lengths, whichever one you want to make length and width, it does not matter. But it's going to have 2 of the 6's and 2 of the 1 values. So I'm going to do 2 times the 1 plus 2 times the 6, and that result is 14. So when I have one rectangle, my perimeter is going to be 14. And doing this algebraically like this in your table is going to help you when we have to write this in words and write our equation. So let's look at 2 rectangles. Again, I have 2 lengths and widths, but this time this is 1 plus 1, so this is 2, so this is 2, so I actually have 2 2's, and again I still have 2 6's. That distance there is not changing. So when I simplify that, I'm going to get 16. So when I have 2 rectangles, my perimeter is 16. So let's move on. When I have 3 rectangles, I have a length here of 1, 2, 3. So this side is 3 and this side is 3. So I have 2 3's, but I still have only 2 6's. And when I simplify that, it's going to give me 18. So when I have 3 rectangles, I have a perimeter of 18. And the last one we have to set up is the 4th illustration here. When I have 4 rectangles, I have 2 4's and 2 6's. And when I simplify that, I get 20. So when there are 4 rectangles, the perimeter is 20. And we've completed the table portion of our problem. So now what we need to do is we need to think about, how can I write this in words? How can I explain what's going on in my table in words? And so this will be just a short paragraph, maybe one fairly long sentence, but that's all you've got to write when you're solving this. So let's think about what's going on here. if I multiply, I'm multiplying 2 times 1, and then I'm multiplying 2 times 2, and then 2 times 3, and 2 times 4. And let's think about, where does this 1, 2, 3, and 4 come from? Where am I seeing this? And I'm actually seeing 1, 2, 3, and 4 here in the number of rectangles. So I'm actually multiplying 2 times how many rectangles I have in my picture. That's where the 1, 2, 3, and 4 are coming from. I'm multiplying 2 times 6. That doesn't change. It's always 2 times 6. So what's happening here is I'm multiplying 2 times the number of rectangles, and then I'm adding 2 times 6 for the total perimeter. Now think again, why do I have 2's here? Well, I have 2 lengths and I have 2 widths. That's why there's a 2. But my length is also represented by how many rectangles are in my picture. So let's just take everything I kind of explained there and let's put this down on paper in words. So let's see, we're going to multiply the number of rectangles, and I'm going to abbreviate a little bit. So multiply the number of rectangles by 2, and that's going to give us, that's going to get the total length. Remember, there are 2 lengths. And add, we're going to add 2 times 6, because the 6's never change. There's always 2 6's in every one of these pictures. So we're going to add 2 times 6 for the total. That gives us the total width. To result in the total perimeter. That's exactly what we did in our table. So just writing or explaining in words what we're doing in our table from our illustration. So we've taken care of the first 2 steps. Now writing the equation should be very simple now, because with the equation we pretty much have it written out for us in the table, and then we've got the explanation of it, equation, we have the explanation of it here in words. We're multiplying the number of rectangles by 2. Well, the number of rectangles is constantly changing. It's not staying the same. So to get our y value, okay, because that's what we're trying to find, that's our dependent variable. To get our y value, which is our perimeter, we've got to take 2 and multiply it by the number of rectangles. Well, the rectangles are changing every time. It's increasing by 1 every time. Next it'll be 5, then 6, and 7. So if we don't know how many rectangles, since it's always changing, that's going to be our x value, and that's exactly what we put up here. The number of rectangles is x. It's the independent variable. So to get our perimeter, we have to multiply 2 times the number of rectangles, and then we add to that, and that's exactly what we wrote in words here, we add 2 times 6 for the total. Well, 2 times 6 is the same in all of these, so it'll always be 2 times 6. So what is 2 times 6? And that is 12. So there's your equation. You could try it out. You could plug in 1. 2 times 1 is 2, plus 12 is 14, and that's exactly what we got there. So just being able to write it in equation. Then we have the last thing, which is our graph, and we have not been given an x and y axis, so we're just have to develop our own. But think logically about this. Will I ever have a negative number of rectangles? And can you have a negative perimeter? And the answer to those are no, you can't. So we're actually only going to be discussing the first quadrant. So when you set up your graph, you could just draw the first quadrant rather than having to draw the entire thing. So let's look at graphing this. Alright, number of rectangles is increasing by 1 every time. 1, 2, 3, 4. So I'm just going to mark this off. 1, 2, 3, and 4, making sure that you label your X and Y axis. So this is number of rectangles, and notice that I put that on the X axis because that is the X value. It's the independent variable. And so our Y's will be 14, 16, 18, 20. So I don't want to mark this off by 1s, and 2s probably wouldn't be too bad. But I think what I'm going to do is I'm mark this off by 4s. So this would be 4, 8, 12, 16, 20, and then that one would be 24. 4, 8, 12, 16, 20, and then 24. So you can set up your y-axis however you would like. I'm just trying to make it so I don't have quite so many markings on the axes there. But let's go ahead and plot these points. So when I have one rectangle, I have a perimeter of 14. Well, there's 12, and there's 16, so 14 would probably be right there somewhere in the middle. When I have two rectangles, it is 16, that's the perimeter, so I'll go up to the 16 mark. 3 rectangles is a perimeter of 18, so not quite to the 20. And then 4 is 20, so I'll go up to the 20 mark. And it is linear. It does appear to form a straight line. We're not going to connect these dots because connecting the dots would indicate that I could add a half of a rectangle, and I'm not going to add half of a rectangle. So you will not connect the dots, but it does appear to form a straight line. So that is an example of a linear function. So table, words, equation, and graph based on your illustration. I want you to take that example and apply it to your turn problem 1. And this is the same basic process. You've got illustration. This one's triangles. Those are 3s. It's kind of hard to see. So this is a 3, this is a 3, this is a 4. It continues on in that same sort of pattern there. And so determine what the relationship is. Make sure you know which is the independent, which is the dependent variable. And you need to create a table, write it in words, write an equation, and graph it, just like we did on the last problem. Now, we're going to move on and talk about functions and linear functions to better define that. We've looked at a couple of illustrations of that. So the first one we're going to define is function. So definition number 5 is function. And function is a relationship that pairs each input value. So whatever the value is of your input, it's going to pair that input value with exactly one output value. Now, exactly one. That means that when you put in your input, whatever you substitute in, you will only get one solution. So putting in one number, you cannot get 2 answers from that one number. That's to make it a function, it has to have one output. Now, a linear function, if we talk specifically about a linear function, because there are functions that are nonlinear. So a linear function is a function whose graph is a non-vertical line or part of a non-vertical line. Now, think about what vertical lines look like. They run north and south. If you have a vertical line that runs north and south, that means that for that one x value, you have infinitely many y values. So basically what it's saying is a vertical line, you have one input and infinitely many outputs. So a vertical line is not a function. It does not meet the requirements of this definition. So any other line, as long as it's non-vertical, and it's a part of a line, so just like our last example, it was a linear function, or it was a function, and it could be linear if we connect all the dots and draw the line if that were necessary, and each input value had exactly one output value. And you've looked at something like this when you were maybe in middle school. It's a function machine, and hopefully you've seen this before. But with the function machine, you have the input or the independent variable goes into the function. Something happens in here. You multiply by 2, you add 4, you take the square root of it. Whatever happens here, and then exactly one output will occur. So maybe square root's not a good example, but squaring, you may have when you put a number in and you square it. We have functions where you can square it, and that will be an output. So there's different things that can happen in here. We're only going to talk about the linear ones to begin with, but whatever you put in, then your output is your final answer, and it has to only be one output. There cannot be more than one. Alright, so we have one more example that we're going to look at that deals with linear functions. So this last example, we're going to represent a linear function from this table. So they've already given us a table, so the only thing we have to do are the words, the equation, and the graph itself. Alright, so let's analyze what's going on in our table. We have number of photos, that is our x, which means this is our independent variable. And so I have 0, 1, 2, 3 number of photos. And then the memory, it's in megabytes, it's the amount of memory left on your camera. So if I have 0 pictures, I have 512 megabytes of memory left. If I have 1 picture on there, then I have 509 megabytes of memory. So let's see what's going on with our table here. Alright, from 512 to 509, that's a decrease of 3. Now this is our original starting position. So if I think about what if I took 2 pictures, one right after the other, I'm going to go from 512 to 506 immediately, and that's a difference of 6. And the same thing here, if I were to take 3 pictures, that would be from 512 straight to 503, and that would be a difference of 9. So you can see that we're going down by 3 every single time. Down by 3 every single time. But from the original amount, it's going down 3, then down 6, then down 9. So let's analyze what's happening here. We're going up by 1, up by 1, up by 1. So our photos are pretty easy. They're increasing by 1 every time. Alright, so what we need to do is we need to think about in words what is going on in this table. Got to figure out what's happening. So the memory of the camera is starting out at 512, but then it's decreasing. Okay, so we know that's 512 minus something. It's decreasing by a different value each time. It's decreasing by 3 here, or it could be decreasing by 6 to get to this one, or it decreases by 9 to get to this one. The next one would be decreasing by 12 to get to the 4th one, which will be for 4 photos. So I'm going from a 1 to a 3, from a 2 to a 6, from a 3 to a 9. The next one would be a 4 to this minus 12 out here. What am I doing to 1 to get to 3? I have to do the same thing to 2 to get to a 6. Do the same thing to 3 to get to the 9. And hopefully what you're seeing here in this pattern is that I'm multiplying 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. So I'm multiplying by 3 every time to get that decrease. So this is what's happening. I want to write this in words. The memory of the camera is 512, that's where it starts at, 512 minus, because remember we're going down each time, minus the quantity. So we've got to take the quantity of 3 times the number of photos. Another way to look at this is, since we're going down by 3 each time, that minus 3, minus 3, that means each one of these pictures is 3 megabytes. So the number of photos, for every photo, it's 3 megabytes. So I've got to subtract from 512 3 megabytes for every photo that I have taken. So the fastest way to do that is multiply 3 by how many photos you have, and then subtract it from 512. So our equation is pretty simple to write once you've got it in words. Sometimes writing the equation is pretty easy, and then you can go to words. It doesn't really matter, whichever way is the easiest for you. But we have it here. If we want to know how many megabytes, if I want to know the y value, how many megabytes do I have left over? So I want to know y. Y is equal to, the memory is equal to the amount of memory you started with, which was 512, minus 3 megabytes times every picture, and pictures are x, times every picture that you have on your camera. So that's your equation. Now, the graph of this is going to be different than the graph we had on the previous example. Again, we're still going to be in the first quadrant because we're not going to have negative photos or negative memory. Once you get to 0, it will not go any further than that. So when I set up my graph, I'm going to draw my x and y axis here. My x-axis, I have 0, 1, 2, 3, and I do not have the 4. That was the one I added. So 0 is obviously right there. So that would be 1, 2, and 3. But my y values, the smallest number is 5, well, actually the largest number is 512. It's going down to 503. So my graph needs to start a little bit lower than 503, but I don't want to start at 0 because that would be a very large jump to get from 0 to, say, 500. So what you're going to do with your graph, and this is actually called a break. If you kind of do a little zigzag line there, that's called a break. What that indicates is that there are several numbers between 0 and the first number you're starting with, which is 500. So that's called a break. Kind of want to connect your zigzag there. And this break just indicates, again, that there's several numbers between 0 and where you're starting. So that's 500. I'm just going to count up by 2s. Since we're going up by 3s here, I'm just going to go up by 2s. You could go up by 3s if you wanted to. So this would be 502, this would be 504, 506, 508, 510, and 512. Alright, so let's graph this. We've got 0 pictures on our camera. So that means we have 512 megabytes. And let's label this. We need to label our x and y axis. This is memory in megabytes. And this one down here is number of photos. So at 0 photos, I have 512 megabytes of memory. When I take one picture, I have 509 after one picture. When I take 2 pictures, I have 506 left. And when I take 3 pictures, I have 503. So it is linear. It does appear to form a line. It is a linear function. We're not going to connect those dots because you can't take a half of a picture. So you're not going to have between 512 and 509 megabytes. But you do have a line being formed, don't connect those dots. You do have a line being formed going down. Eventually, you're going to get to a certain amount of photos that causes you to have 0 megabytes of memory on your camera. Alright, so take this linear function representation here and do this your turn problem. A little bit smaller number, so it should be a little bit easier. Now I want you to describe this relationship using words, an equation, and a graph, just like we did the last problem. This one doesn't have anything special as far as photos and memory and that sort of thing. It just has inputs and outputs, but still make sure that you label your X and Y axis on your graph. Alright, so that concludes this learning target. So you have 5 summary questions here I'd like for you to answer. Each one of these represents some of the questions that or the 2 questions that we've done here. Question 1, graph each one of those ordered pairs and use words to describe the pattern shown. What's happening, basically. You don't have to create a special X and Y axis. If you want some graph paper, that's fine. It doesn't have to be perfect, but just plot those points and then explain to me what pattern is that you see for each one of those, 1, A, B, and C. Number 2, you need to complete that table to show the relationship between the number of squares and the perimeter of those being formed. So just fill in the missing pieces to this table. That is an N, so think about this would be your equation. What would that look like if you didn't know the number of squares? 3 is a vocabulary question, so be sure to read through that and answer that one completely. And then 4 and 5 reasoning questions. Please make sure that you justify your answers and explain completely.